All right, let's do arithmetic circuits. We're going to start with a half adder. We're going to draw it up, draw the truth table. Then we're going to put it and code it in Verilog so you can see. Okay, we added these rules. Previously, we had just our OR truth table and our AND truth table, but now we're using NAND, XOR, NOR, XNOR. So a half adder has two inputs, a sum and a carry out. Just two inputs, and for this one we're going to use A and B. If you do in a regular arithmetic, 1 plus 1 equals 2. We don't write 2, we write 1, 0 in binary. And the most significant bit, that is the carry bit. The least significant bit on the right, that is the sum bit. So the carry out bit is here. Here's our sum bit. Now let's start. We're going to use two inputs. So that's 4 combinations. 0, 0, 0, 1, 0, 2. Those are our 4 combinations. Now, there would be no sum and no carry out for these two if you had all zeros. For this, 0 plus 1 is 1. No carry out. Same thing. No carry out for 1 and 0. Now, 1 plus 1 is 2. You're going to have a carry out. Remember, 2 is binary is 1, 0. The carry out, the carry bit for 1 and 0 is 1. Now let's look at the truth table and see what patterns we find. So let's look at the sum column. Then we'll look at the carry out column. Find when the best thing to do is to find when the the value is 1. Okay. So right here, find when the value is 1 and then apply the rule here. Here we have in the sum column, these two values are 1. What do you see about the inputs? 1 is high, 1 is low. So what rule applies there? Outputs high if inputs are different. Yes, that applies. Outputs high if their inputs are different. These inputs are the same, the output's low, so that applies there. It applies there. But let's also look at or outputs high if it's at least one input is high, because that rule applies, correct? Right? Yes. But at least one input is high. So look here. These two inputs are high and the output is low. So you can't use OR for sum. So it has to be a XOR gate. And here's how you write AND OR XOR not. So it has to be A XOR B for the sum. Let's do the same thing for carry out. Let's look at when the values are 1 in the very last row. Don't look at this. Look at the A and B. Both outputs high. Carry out's high. Outputs high when all inputs are high. That works. Does it work for the other rows? These are low and are low. Outputs high. One's high, one's low. The output's low. Remember, it has to be high. Output has to be high. All these have an output of low if you want, if one, if not both are high. Now let's take these and build our circuit. We'll call it a half adder circuit. We need our two inputs, A and B, and our two outputs, sum and carry out. This is, remember, this is a combinational. So we use a continuous assignment like we've been doing. Refresh it. Oh, no, it's working. There is your carry out. There's your sum, carry out sum. This is your half adder. Now let's do a full adder.